Welcome to factoring using special products, and here are the three formulas that I will reference throughout this section. I will refer to them as the green formula or the difference of squares formula, the blue formula or the difference of cubes formula, and the red formula, which is the sum of cubes formula. Here is the first example. Your first task when you are trying to recognize if it is even a formula that you could use to factor would be to compare the sign inside of your question, ours is negative, and the exponent that the variable has, ours is 2, to the three signs and exponents of the formulas. Well, clearly this looks like the green formula because the sign is negative and the exponent is 2. So our task is to write the right side of the formula and then we will be done. To write the right side of either of the formulas, we have to know A and we have to know B. Once you know A, you will replace this A and this A with your specific A, and when you know B, you replace the B's with your specific B. In this question, your A will come from y squared and your B will come from negative 9. Difference of squares, which is your green formula, all you have to do is recognize a certain pattern. Y squared is y times y, and 9 similarly is 3 times 3. Once you recognize this, you will have your A and your B. Y is your A and 3 is your B, and all you have to do is write A minus B and A plus B using your A and your B. So the factored form here is y minus 3 and y plus 3. I want to do another example with the same formula. Again, you see w squared, so it has to be the green formula if it was a formula, and then you also see a minus. So here, to determine our A and B, you will break down 100 into 10 and 10 and w into w times w. Your factored form would be 10 minus w and 10 plus w. Notice that while it's tempting to write w minus 10 and w plus 10, because 100 came first in the question, the 10 has to come first in the factored form. The next two questions will be using this blue formula. So I'm going to repeat the formula on the screen so I can reference it, and then we'll go through the example. So here is your formula on the top of the screen, and then the question is 2 factor w cubed minus 27. Again, you see the negative symbol which matches the negative in the formula, and you also see the power of 3 which matches the exponent in the formula. So you know this is your formula. To be able to factor, you again have to have the A and the B, because once you have your A and the B, you just replace each A with whatever your A is and each B in the formula with whatever your B is. Very similar to the difference of squares, for the difference of cubes, you would have to break your original terms down. But instead of breaking them down into two identical multiples, you would be breaking them down into 3. So w cubed is simple. It's just w times w times w, and that w is your A. For the 27, you have to think about a number that multiplied by itself 3 times would return a 27. That number is 3. 3 times 3 is 9, and times another 3 is 27. The 3 will be your B. So now we just have to follow the formula to write the factored form. The first thing I see in the formula is this first set of parentheses that tells me to write A minus B. So for my question, I will be writing W minus 3. The next set of parentheses here, the first thing I see is taking the A, which my A is W, and squaring it, so that will be W squared. Then a plus sign here, so I will repeat that. The next thing in the formula is a multiplied by b. So I have to multiply my a, which is w, by my b, which is 3. So you can just write 3w. Finally, again, a plus sign, so plus. And then the last term in the second set of parentheses is b squared. My b is 3, so b squared, or 3 squared, is 9. So I'm just going to write plus 9. That's it. You're done. Let's look at the question now that uses the last formula with the plus and the cube. So that will be on the next screen. Here's your example. You have 8x cubed plus 1. And since you see the plus and the cube, you know it's the formula of the sum of two cubes. You again have to have your a and your b. So you're looking at the original two terms and you're trying to break them down into three identical multiples. For 1, it's very simple. To get 1, you can multiply 3 ones together. So your b is 1. For a, you have to incorporate both. Whatever you multiply 3 times to get the 8, and whatever you multiply 3 times to get the x cubed. So for the 8, it's 2. 2 times 2 times 2 is 8. But then each 2 also has the x to make the x cubed. And you can always check 2x times 2x times 2x is 8x cubed. So there is your a. 2x is your a. So now we will be writing our formula as it tells us to write it, a plus b in the first set of parentheses. So my a plus b will be 2x plus 1. I'm going to continue with the second set of parentheses, and it tells me to take my a and square it. So I have to take my a, which is 2x, and I'm going to write it in yellow here, 2x, and I'm going to square it. Now squaring it means multiplying it by itself. So be careful, make sure you don't write 2x squared. Make sure you write 4x squared, because you have to square both the 2 and the x. So 4x squared. The next thing in the formula is this minus, so I'm repeating that. And then it tells me to take my a, which is 2x, and multiply by my b, which is 1. So 2x times 1 is 2x. Finally, plus b squared, and square my b is easy. 1 squared is simply 1. That's it. So this last factoring question here I wanted to show you because the original question will have a greatest common factor. So if you have 3x cubed minus 147x and you're asked to factor it, it's tempting to say that this is the difference of cubes because you do see this x cubed and you also see the negative. However, what you need to recognize is, first of all, 3x cubed as is cannot be broken down into 3 identical multiples. You cannot multiply anything by itself to get a 3x cubed. And the same story with 147x. So you have to recognize that both the 3 and 147 are divisible by 3. So 3 is definitely the greatest common factor for 3 and 147 and needs to go outside before you do any other factoring. In addition to that, you have x to the third and x to the first. So we have to take out the x with the smallest power. That would be x to the first for us. And then we'll describe what happens to the original problem. X cubed became x squared, and 3 turned into 1 because you divided it by this 3. And then 147 became a 49 because you divided it by the same 3, and what 49 doesn't have an x next to it. Once you factor out 3x, you will see that the inside actually changed to the power of 2, and that makes it the very first formula. So I'm going to copy the formula. And this here is what you have here inside of the parentheses, and this is what you need to write, keeping the 3x in the front of your answer. So since this is squares, we will be breaking our original binomial down into two multiples for each term. So this is x, and this is 7 times 7. Keeping the 3x in the front, I'm writing a minus b, which would be x minus 7, and a plus b, which would be x plus 7. So the next question will show you how to solve equations with these factoring techniques. Here's a quadratic equation, and I know it's quadratic because the exponent of the variable is 2. So you have to think factoring. This is the first formula, the difference of squares, because you can break m squared down into m and 1 into 1 times 1, and you do have that minus in the middle. So the left side, according to our first formula, will become m minus 1 times m plus 1, and you keep writing equals to 0 since that's an equation. Just like with all of the other factoring, when you're solving equations, take each factor and set each equal to 0, and then solve. So for the first one, take this negative 1 out to the right, and that means your first m is positive 1. And then for the second problem, take positive 1 to the right, make it negative, so your m is negative 1. And here's the last final question. This is also an equation. You are asked to solve it. You see an equal sign. You see all of these exponents, so you know you have to make sure it's equal to 0 in order for you to be able to factor. For that, I will take k squared. It's a positive k squared on the right, so I'll put it here and make it a negative k squared. And I will do the same with positive 175k. I'll put it here, make it a negative 175k. And when you write in your left side with these two additional yellow and green term, make sure that you put your k exponents in descending order. So you first put the largest exponent of k, then you will write your yellow k squared with the negative, then the green 175k, and then finally the positive 25 that was already there. Well, some of you may wonder what this 4-termed polynomial is doing in this section, because 4 terms is not any of our formulas, and the 4-termed polynomials we factor using grouping. You will see how this is related, but if you were thinking grouping, you were right. So let's go ahead and group 2 at a time and pull the GCF. So from the first group, I'm going to take k squared out, which will leave me with 7k minus 1. From the second group, I will take a negative 25 out, which will leave me with 7k minus 1. I'll keep writing equals to 0. You got your 7k minus 1, that match. And then the remaining terms are k squared minus 25. And what you need to recognize here is the second binomial here is the same formula as we saw in this question number 1, which is the difference of squares. So k squared is your a squared, so that's k times k, and 25 is 5 times 5. So that underlined binomial can be broken down even more into k minus 5 and k plus 5, with the 7k minus 1 in the beginning. And here you have 3 factors. Each of them will have to be set to 0 to solve for k. Now keep in mind, again, I already mentioned in one of my previous recordings that the number of solutions to your equation always matches the number that the highest exponent of k has, so that's a 3. So you should have 3 factors and 3 solutions at the end. If you get 2, that means you didn't finish factoring. So we're going to take, I'm going to write here, 7k minus 1 equals to 0. Add the 1, divide by 7. So your first k is 1 over 7. Now we're going to take the second factor from that broken down polynomial. We have k minus 5 equals that to 0. Add the 5 to get k equals 5. And then we're going to take the third factor, that one was k plus 5, set that equal to 0. Subtract the 5, so k is negative 5. Those are your 3 answers to this equation.